Today we're going to start to take a look at function operations, and we're going to look at how we can add, subtract, multiply, and divide. So let's look at an example. If we have addition, we have f plus g of x. That's going to equal if we take the function of x and add it to the function of g. Subtraction, if we have f minus g of x, that's going to equal if we take the function of x and we subtract it from the function of g. Multiplication. Move that over a little bit. For multiplication, we have if we take f times g of x, that's going to equal f of x times by g of x. And lastly, division. If we have f divided by g of x, that's the same as taking the function of x and divided by the function of g, so long as that function of g does not equal 0, because we cannot divide by 0. Alright, let's take a look at some examples of adding and subtracting. First we want to find f plus g. So here's our f, here's our g. So if we want f plus g, that's going to equal f of x plus g of x. And we know that f of x is 3x plus 8. And g of x is 2x minus 12. So if we add those together, 3x and 2x become 5x. Positive 8 and a negative 12 become a negative 4. So when we add those two, we get 5x minus 4. And their domains are all real numbers. There's no limitations. So let's take a look at f minus g. So if we take f minus g, that's the same as saying the f of x minus g of x. F of x is 3x plus 8. Now we're subtracting all of 2x minus 12. So that needs to be in parentheses, which tells us we need to distribute that negative 1. So now we end up with 3x plus 8 minus 2x plus 12. So now when we simplify that, 3x minus 2x becomes a 1x. 8 plus 12 is 20. So f of x minus g of x is x plus 20. And there's all real numbers for our domain because there's no implications. Let's look at another couple examples for adding and subtracting. So first let's find f plus g. So f of x plus g of x equals f, which is 3x squared minus 4x plus g of x, which is 2x minus 5. So combine like terms, there's nothing to combine with 3x squared. Negative 4x plus 2x becomes a negative 2x, and then negative 5 by itself. And this one also has all real numbers. So let's take a look at subtracting f and g. So f of x minus g of x is going to equal f of x, which is 3x squared minus 4x, subtracting all of 2x minus 5. So if we distribute our negative 1, this becomes 3x squared minus 4x minus 2x plus 10. So 3x squared, negative 4x, and a negative 2x become a negative 6x plus 10. And our domain is all real numbers. Alright, let's look at multiplying and dividing now. Multiplying, we want to find f times g, so f of x times g of x is going to equal x squared minus 1 in parentheses times by x plus 1 in parentheses. And now we get to FOIL. So x squared times x is x to the third. X squared times 1, x squared. Negative 1 times x is a negative x, and negative 1 times 1 is a negative 1. And there's nothing we can combine like terms, so that's our final answer. And our domain is all real numbers. So now if we look at f of divided by g, we're just going to set this one up. It would be the same as f of x divided by g of x. And f of x is x squared minus 1 divided by x plus 1. Now the domain, we can't have our denominator be 0. The only way that happens is if x equals a negative 1, because negative 1 plus 1 is 0. So x cannot equal negative 1. So those are our answers. Right, last example is for multiplying and dividing. So if we multiply f of x times g of x, it's going to equal 6x squared plus 7x minus 5 in parentheses times by 2x minus 1. Now let's distribute, multiply all this out. So start here, so 6x squared times 2x is a 12x to the third. 6x squared times a negative 1 is a negative 6x squared. 7x times 2x is a positive 14x squared. 7x times a negative 1 is a negative 7x. Negative 5 times 2x is a negative 10x. And a negative 5 times a negative 1 is a positive 5. So now if we combine our like terms, 12x to the third, there's nothing to combine it with. Negative 6x and a positive 14x squared, those combine together to be a positive 8x squared. Negative 7x and a negative 10x combine to be a negative 17x plus 5. And our domain would be all real numbers. Last example, let's look at what happens when we divide these two. So f of x divided by g of x. We're only looking at doing the setup for division. So we have 6x squared plus 7x minus 5 divided by 2x minus 1. So here, to find our domain, it's not going to be all real numbers because we can't have the denominator be 0. So what happens, what does it need to be? So if we say 2x minus 1 equals 0, we can add 1 to both sides. 2x equals 1. Divide both sides by 2. X equals a half. So when x equals 1/2, this is going to equal 0. So x cannot equal 1/2.